welcome back. We're going to do number 9, 10, and 11 all in this video. Let's try to finish out page 2. We're going to start trying to find the inverse of a function. So our steps for this are actually quite simple. First, change it from function notation to our normal notation, which is just replacing our f of x or g of x into just a y. And then this is the step of actually finding the inverse. Alright, what we do here is switch y and x. So now we get x equals 2y minus 6. This is a quite simple function, the one that you might see on the test. If you do see this on the test, might have some powers in it, so be ready to look back at that test that we had. I think this is Unit 2, where we could try to practice a little bit more complicated of functions. But now we still want to get the y by itself. So at this point we do have our inverse function and we're just simplifying it to y. So now we want to add 6 to both sides. Remember, when we're doing this we have to go the opposite order of PEMDAS. If you are somebody who gets switched around real quick, you can write down PEMDAS, arrow. We have to deal with the subtraction first. So you have x plus 6 equals 2y. I'm going to rearrange this real quick just to have y on our normal side. And then now let's try to get y by itself. So now we don't have any addition to deal with, but now we can deal with this division. So we have y equals x plus 6 over 2. Be ready, again, this is multiple choice exam. So this might also look like x over 2 plus 3. So that would be our inverse. This complicated a couple people on the test. We can also show that this is the inverse by doing f inverse symbol, which is that -1 in the exponent, x. So that's how we would write the function notation. We would slip it down into the left there. This is the inverse notation, so please don't be confused about that. We aren't literally doing the exponent of -1. That's just showing that's the inverse. We can prove that this is the inverse, which we did have to do on the test, which we won't have to do on our midterm, but we can check if it's the inverse by actually doing, if these are our two equations, let's just do the one with just a fraction out in front. We can compose these together, and if they are inverses, we would get x both ways. So we would have to do 2 times 1/2 x plus 3 minus 6, and then we would have to do 1/2 of 2x minus 6 n quantity plus 3. And if both of these equal x, then we know we did our inverse correct. So here we distribute the 2, so we get x plus 6 minus 6, we get x, that's good. Over here we distribute that half, so we get x minus 3 plus 3, so we get x. We're good here. Alright, we did our inverse correctly. So if we move on to number 10, now we have to find the vertex and the axis of symmetry. We did 2 different ways to find the answer here. First we talked about the completing the square. Not a lot of you guys like that version. I'll go over that one first, and then on another slide I'll go over just using a formula that we just had to memorize. I'm going to switch colors here so you can always remember that we're doing the completing the square method. So with completing the square method, we have to factor out this a from the first 2 terms. So we get y equals -3 times the quantity of x squared. I'm going to divide that -6 by -3. So I get plus 2x, and we really don't care about this information at the end. We won't use it until the very, very end. The next step is that funky step that a lot of us always got tripped up on. What we're going to do is we're going to take this 2, divide it by half, and then square it. Divide it by 2 and then square it. So 2 divided by 2 is 1, 1 squared is 1, and I actually have to add and subtract that number on the inside. Since we're not doing one thing to the right and one thing to the left, since we're adding something in, we also have to add its opposite in. So that way we're not actually changing anything about this equation. So that would be the next step. Now we want to get just this chunk right here by itself, so let's distribute that -3 all the way to the end. Alright, it's still on the first couple of terms here, but we did distribute that negative 3 to negative 1, so that's plus 3 minus 9. So now the fun part and the reason why we did this is now we can see that this is a perfect square of a binomial, and that binomial is x plus 1. Notice how we got 1 when we did 2 divided by 2. That's where that positive 1 came from. There's a square on this binomial, and now we have negative 6 on the outside. To find our vertex, all right, we take the number on the inside of the parentheses and we have to find the opposite of it, so that's negative 1. And then we just take the number that's all the way out to the left, to the right, which is negative 6. That would be our vertex. Our axis of symmetry, which we can just shorthand that as axis, that's always going to be a vertical line, so x equals, and then we just steal the x value from the vertex. So for this question, our final answer is our vertex is equal to negative 1, negative 6, and then our axis of symmetry is that vertical line, x equals negative 1. Our second method of doing this was just using a formula, which the majority of you guys like doing it this way, but we do have to memorize this formula for the midterm then. Let me rewrite the quadratic that we started with, which was negative 3x squared minus 6x minus 9. First we found for our vertex, we have to find the x value, and our equation for that is negative b over 2a. If thinking about the quadratic formula, that might help you remember this. So we take negative our b, which happens to also be negative here, so we have two negative signs on the top, and then 2 times negative 3 on the bottom. So we get negative 6 divided by negative 6. That math is easy to do in our heads. No, it's not, because somehow I screwed up the numerator. Positive 6 divided by negative 6, so we get negative 1. There is a formula for the y part, but I just find it easiest to plug it back into our original equation. So negative 3 times negative 1 squared minus 6 times negative 1 minus 9. So here we get negative 3 times 1 plus 6 minus 9. And if we do that real quick, we'll get negative 6. So again, just like we got with our other method, we get our vertex as negative 1, negative 6. And then just like over there, our axis of symmetry is x. It's always that vertical line. And we steal our x value from our vertex. So x equals negative 1 is that axis of symmetry. Lastly, for this video, we're going to go over number 11, which is how to find the number of complex zeros for each function. In class, we talked about two different things. We talked about our complex zeros and our real zeros, which we also called the roots. Alright, so we had two different ways to think about this here. Our complex zeros. This one was the easy one. The number of complex zeros just equaled the largest exponent, which here would be 4. So our answer for number 11 is 4. To find our real zeros, which are also called our roots, we have to graph it and count the number of times our curve crosses the x-axis. Alright, this was not what the question asked, but I did want to go over it just in case you were going over this problem and you thought it was more complicated and did remember some of the stuff on the right. But what's on the left, it is that easy. Just take the largest exponent and that is your answer